Hello, everyone. Welcome back. We're here with Piper Thunstrom, and she is going to be talking about making games with PPB. So we were chatting backstage. Would you like to share what PPB stands for?
PPB actually stands for PursuedPyBear. It's reference to a fairly obscure piece of Shakespeare stage direction. um,
Nice. Perfect. And she is an open source maintainer of this project and very much excited about making games. So we'll go ahead. Was there anything else you would like to share, Piper?
no, I think I can. If anything comes up, we can cover it afterwards.
Awesome. She'll be around with the Q&A. All right, let's get started.
Hi everyone, thanks for tuning into my talk. This is Making Games with PursuedPyBear. I'd like to thank the organizers for welcoming me to PyCascades, and I am Piper Thunstrom. I'm a senior software engineer at Zapari, where I do web development with Django. I'm also an open source maintainer. I am the author and one of the core maintainers of PursuedPyBear, which we're talking about today. And I am also the author of Misbehave, which is an early alpha behavior tree library. I also do some other small video game stuff. There's a lot of open source video games and things like that on my list. This talk. So I would like to introduce to you the building blocks of PursuedPyBear. The goals are, by the end of this talk, I want you to be comfortable downloading PursuedPyBear and starting to hack on your own video games. I would like to pass on some wisdom on how to think about game creation. I want you to be able to understand what events are and how they interact in the game, which includes the event loop. The purpose of and use of scenes, and the difference between sprites and other kinds of game objects. So, why am I pitching PPB as the core of this? The primary thing is PursuedPyBear is an education-focused game library where we have attempted to reduce the complexity of building video games so that you can focus on lesson plans when using it. The thing is, that also makes it really good as a tool for other developers. For a developer, one of the things we really pitch is how easy it is to get started, but it also lets you focus on the problems you care about in your game at one at a time, and it's deeply extensible, allowing you to override and replace any bits of the system that aren't working quite the way you want. So how fast can you get started with PPB? 2 lines of code. First, import PPB, and then ppb.run. With that, you get an open window, which is way faster than most libraries. I do want to talk about one of the parameters to this run function before we move on. Primarily, this is our setup function. If we define ourselves, def setup, and you can name this anything, we just call it setup by default. It takes one parameter, scene, and we'll pass for now. We'll use this a little bit later. But if you pass this function here, when you run it, well, it doesn't do anything different yet. That's because we haven't done anything in our setup function. But we can use the setup function to put objects into the game scene and put them on screen. So what do you put on screen? They're called sprites. So sprites are visible game objects. They're used for things like player characters and NPCs, anything that's going to move on screen and your players can react to. One of the nice things in PursuedPyBear is that we have developed an init that takes arbitrary data values as keyword arguments and sets them on the sprite for you. So you don't have to define your own sprites until you need to modify those values at runtime. So let me just show you how this works and talk about some of the important values that you'll be using. So we're going to create a sprite, ppb.sprite, and we're going to add it to the scene. We run this code, and we have an object on screen. What if you want to change its color or the image entirely? Well, PPB provides a number of assets, including things like images, but we're going to use our shape assets. So ppb.square, and we're going to make ours a middling shade of green here. We run this code, and we have a green block. Now, you've seen it spawn rendered at the center of the screen. What if we want to move it around? All sprites have a position, which tends to be a PPB vector, though at instantiation time, you can use a tuple or a mapping. Let's put it to 5, 5. And if we run this, you'll see we've moved that sprite. You can move this anywhere you like. So what else might you want to do with a sprite? Maybe the direction it's facing isn't quite right. So sprite.rotation. Here we go. Let's angle it at 35 degrees. If we run this code, we now have a slightly cockeyed box there. And then the last thing you really need to worry about for putting objects on screen is the size attribute. So if we set this to, say, 3, and we run our program one more time, the box is much bigger. This also accepts floats, so you can do smaller objects. All right, putting things on screen is important to games, but really what makes video games is being able to move them over time. So we're going to demonstrate how to do that and start talking about event handlers. In PPB, everything is event-driven, which means we provide the game loop and send events to all of your objects that you can respond to with your code. In order to make sprites move, you actually have to use the event system. The nice thing is, all events in PPB follow a pattern. So we've been using the base sprite here. Let's actually make our own class. So class player, PPB sprite. We don't need an init because it was already set up, but we do want to set some defaults here. So we're actually going to take our image attribute and our position attribute and set them at the class level. Remove that. Okay, so we've done that far. We can now remove all of this and replace this with our player. Let's remove our rotation. We don't need that anymore. Now, the most important event handler that you're going to work with as a new game developer is def on update. All event handlers follow this following pattern. The name of the handler is on underscore, and then the name of the event in snake case. In this case, it's just a single word, update, so it's on update. It's a method, so we have to have self. And then we take the event itself, which we can name update event, and then type hint it as a PPB events.update. The last argument to a handler is the signal. Signal is a function. We'll talk about it in a bit. So, what do we do on update to move our character? What we're going to do is self.position plus equals self.target. We'll set this in a moment. Self.target minus self.position. Because we have vectors, we can subtract one vector from another and get the direction and distance between the 2 points. And then we want to scale to, this is going to be an arbitrary speed of 4. And then we multiply it by update event dot time delta. All right, so this one line of code is going to allow us to move from one location to another over time. And to demonstrate this, we just need to starting at 5, 5. If we give it a target equals ppb vector minus 6, so that we can see this. There we go. It's going to move from one side of the screen to the other. The thing to know is this right here is the most important part of this equation. When you're doing simulations, you actually want to do all of your simulations over time based on a time parameter. You can go look up physics equations for how to actually make this work, but this is how you can do just basic directional movement with it. This is actually so that you can change the simulation rate and the frame rate without breaking your code. It will let your game continue to run about the same way no matter what the frame rate is. So now that I've shown you how to respond to events, let's talk about making our own events. This is actually going to be really helpful for making different parts of your game interact. So what are events? Events are a thing that happened or a thing that should happen. In PPB, we tend to call the second category command events or protocol events. To give you an idea, here's a brief list of PPB-defined events that you might actually care about as a new user. There's the update event, which we've already shown off. This is how you simulate your game. It has fixed time deltas, so you can do your simulations over time. It goes about every 60 frames a second. Then there's the key events, both key pressed and key released. This is used to interact with the keyboard and how you would take player input. We then have the mouse events, which mouse motion, button press, button released. These will tell you what the state of the buttons are, which buttons was pressed or released for those two, and the position of the mouse at the time of the event. This is so you can do things like clicking on objects. You can use a simple collision detection algorithm to do that. And then you have the pre-render. This is really, really good if you want to update the presentation of your objects at the least, only when it matters. If you update the pre-render during your update event, the update runs about twice as fast as rendering does. So what you should do is use pre-render when you want to update things like the image and primarily the image is the one that you worry about. So how do you define your own events? So because PPB is an event system, usually you have a way to extend that event. For example, in Pygame, there is the user event types that you can send into the system. In PPB, because everything is class defined, all you have to do is write a new class. One of the only points of that is your event must have a globally unique name. And by globally unique, we just mean for your program. So you can't have your own update event. But the best practice for these events is that they should only contain data. So just simple attributes, which makes them a really great place to use data classes. So to demonstrate this, I'm going to all right, so we're going to import a few things and data classes dot data class. So because I don't have mechanics for this, I'm going to just call this my event for the demonstration. It's just a simple class, and we're going to just give it a source. This is the object that decided to send the event, and it's any type. So any sprite that we make could use this event to do whatever we decide to make it do. In order to send it, we're going to use on button released self mouse event PPB events dot button released, and that signal function, which we'll explain right now. All right, so what we do is where we click, we're going to do signal my event self, and as part of this, let's change the target. Self.target equals mouse event dot position. So this is going to signal out an event and let us change where our sprite is going. As you can see, as I click around the screen, it's going to go after it. Now, you don't see it doing anything else, so we're going to cheat a little bit. We're also going to give this a def on my event, my event, signal. And when the first time we click, we're going to do self.image equals ppd square, and we're just going to make it red instead. Okay, and we run it again, and when I click, it's now a red square. All right, so that's basically how you could define your own events, which allows you to communicate between various game objects. Our next concept is fairly simple. We're going to talk about scenes. So what a scene is conceptually a part of a game. And when I say a part, I don't just mean worlds like in certain video games. Each menu is often its own scene. Credits are often their own scene. Each level tends to be its own scene, except in like open world games, where they use way more complex systems for that. The other thing you need to know about scenes in PPB is that they are containers. So you can put objects into them. This is actually important for the way PPB works. Primarily, inside the engine, PPB stores scenes as a stack. This means that we have the basic stack operations. We can push, we can pop, we can do a pop and then a push, and we can also peek. The engine actually does that to determine which scene to send events to. So only the currently running scene gets any of the events that we've signaled in this example. The way that you actually go between scenes is a series of events, which I will cover very quickly here. There is the start scene, which is our stack push operation. There's replace scene, which is pop then push. And then there's stop scene, which is just pop. Clever use of these three mechanics allows you to do a lot of interesting tricks, like putting a temporary scene up and then pulling it off so you go right back into the game that you were playing. Other thing, which is really good for like pause menus, you can also do, if you back out of the game, it can go back to the splash screen and restart. And besides those three events, there's also a series of lifestyle events so that you can change the state a little bit. It's really good if you're using real time in a scene. You can pause that timer on the life cycle events. So how would you actually use these? Well, you should make a new one for every menu, every splash screen, and every level of your game. Don't actually worry about code reuse here. Reusing code in video games can get really finicky. So when you're first starting out, you should just let each scene be its own independent thing, even if you have to copy and paste some code from one scene to another. All right, so let's demonstrate this. We're going to change this setup function into a class. So we just do class game, and it is a PPB base scene. Just like everything else, our inits can actually def init. We're just going to take kwargs, because just like every other object in PPB, just like I mentioned for sprites, you can use arbitrary keyword arguments to add extra data to scenes. We need to do our super init kwargs. And then we'll move this in, and we just change scene here to self. And then down here, instead of passing in a setup function as we did before, what we're going to do is a starting scene equals game. All right, so just to demo that this still works. The other thing I want to mention, I did say that the scenes do have that same magical init. They can respond to events just like everything else. This is because everything in PPB is what we call a game object. Game object is a parent class that we use. It gives us the magic init. Importantly, what it allows is the scene graph. Every game object can take other objects, including sprites. I didn't really cover subsprites specifically because they're a fairly advanced topic. But for now, what you can know is that you can nest any game object under another game object. This gives you the graph, which makes it very easy to publish to the right things at the right times. This is how the scene stack works. Because sprites exist in scenes, because we're only publishing to the top of the scene stack, only objects under the top of the scene stack are getting events. Now, the other thing you can do with these, so you can import game objects from what we call gomlib, G-O-M-lib. When you do that, you can get a game object that doesn't have all of the other niceties that a sprite has, which it makes it really good for things that you just need code that can respond to events, but you don't need it to show up in the scene. It beats having to go image equals none and other kinds of tricks that you have to do with a sprite. So, I'd like to end with a couple of tips. First, games are complex. There's a lot that can go wrong with them. Don't worry if you feel like you're a little over your head. It really just comes with practice. I definitely suggest start simple. Don't worry about a bunch of things. Start with one object at a time. For example, if you're working on Pong, worry about one paddle that gets controlled by a player, the ball that bounces. Do one thing at a time until it works, and then move on to the next feature. And while in Python we like things to have one way of doing them, in video games it's very rarely true that there's one way to solve a problem. There are a lot of creative solutions, and most of them will work somehow. All right, so in summary, the building blocks of a game in PPB are sprites, scenes, and events. If you can use the three of them together, you can make a lot of projects. PPB supports progressive complexity. Remember, you can start with a setup function and a built-in sprite. You can move to scenes when you need event handlers. When you need event handlers on the scene, more complex setups, if you need some shared state, or if you have more than one scene. And then finally, I didn't get to talk about it because I just don't have the time, but there is a thing called systems in PPB. These are objects that work across scenes. So if you ever need code that needs to live somewhere that it can affect more than one scene, consider looking at the subsystems. All right, so if you want to learn more, you can come join my live streams on Sundays at twitch.tv/PA You can follow me on Twitter at PA Thunstrom, or you can follow PPB itself at PursuedPyBear. The website for PPB is ppb.dev, and the documentation lives at ppb.readthedocs.io. Would be really great if you go to the website and join our Discord. You can come join the conversation. We have a Making Games channel for anyone who's trying out something new. And the docs will give you a lot of options for ways to use this engine. Thank you, and have a good day.
Thank you for the wonderful talk, Piper. That was amazing. I'm very excited to try and make some games now. I've never given it a try.
I'm actually planning to be around for sprints tomorrow. If you want to come chat with me, I can help with that out.
Very exciting.
Open to anyone, obviously.
Perfect. Open invite if anyone wants help from the Audrey creator of PPB. All right, so Piper is going to head on over to the Q&A room, and that is down in the corner. Oh, I think this way. It is that Q&A for the taped talks. So thank you, Piper.
All right.